Okay, Assalamualaikum and hi everyone. Right, today I would like to discuss about tutorial 7.1F. It's about the strength of weak acid and weak base to the respective dissociation Ka and Kb. Right, we take a look at question here. Right, the table show the base ionization constant Kb for several selected compounds. So we have 4 compounds here, right? Arrange the compound in order of increasing strength of base, right? So which means we have to arrange from the weakest base to the strongest weak base. So how to solve this problem? So we have to relate back to the weak base dissociation equation. Right, so let's say we have B is stand for the weak base. Okay, dissociate in water. Okay, so since this is a weak base, so it will dissociate partially. So you have to use reversible arrow. Right, so H2O it will dissociate and become H plus and OH minus. Right. Okay, since weak base, it contains a lone pair. Right, so it can accept a proton from H2O. Okay, therefore the product form here is BH plus. BH plus and OH minus. When we write the Kb expression, Kb is equals to concentration of BH plus times OH minus. Right, so since water here is in liquid, this is aqueous. Don't forget to write the phase. So liquid is not considered. Okay, so therefore for the Kb expression, so concentration of the products divided by concentration of the reactant. Okay, so H2O is not included. Alright, so next, okay, we have to refer to the relationship between the concentration of OH minus and Kb. So we know that when the pH plus POH is equals to 14, strong weak base, suppose it has greater value of pH. So meaning that pH greater, so therefore the POH would become lower in order to get pH higher. So because of that, POH is lower, which means we know that POH is equal to negative log concentration OH minus. So in order to get value of POH is lower, so therefore the concentration of OH minus should be higher. So when the concentration of OH minus is high, so meaning that the value of Kb would become high also. So because from here we can write the relationship. So Kb increase. Why Kb increase? Because of the concentration of OH minus increase. And then the value of POH would become decrease. And the pH will be higher. So because of that, the solution is more basic. Right, so for this question, so we have to arrange in order of increasing strength of base. Right, so we have to refer to the Kb values. So the strongest here, it should have the higher value of Kb, which means the strongest here is NH3. This is number 1. Okay, next followed by N2H4. Okay, next NH2OH. And the weakest here is C6H5 and H2. So the name here is aniline. Okay, this is number 4. And then we have to arrange increasing order, which means start with the weakest. So weakest here is C6H5 and H2. So increasing, so smaller than NH2OH. Okay, smaller than N2H4, smaller than NH3. Right, so there are two ways that you can answer this kind of question, whether you can use the symbol here or you can use arrow, comma and arrow. So if comma and arrow, right, so the answer would be, okay, you replace smaller than with comma. Okay, make sure you have to label it. So with arrow and label. Only two way that you can answer this kind of question. Alright, so for question B, give the structure of conjugate acid for each of the compound and arrange them in order of increasing strength of acid. Conjugate acid is the product form when a base accepts a proton. Meaning that you have to write the formula for the product form when weak base or base accept a proton. Okay, we start with NH3. Okay, so for the structure of NH3, actually it has a lone pair on nitrogen atom. Okay, like this. So that's why nitrogen is able to accept H+. Okay, H+ will attach to the nitrogen atom. Okay, and it would become ion. Okay, so actually it will form dative bond here. Okay, dative bond we use arrow to show a point from the donor to the acceptor. However, for this question, you can just write the formula. That is NH4 plus. Okay. Alright, next for N2H4. Okay, N2H4, actually the structure here is we have two center atom and each of the nitrogen atom has a lone pair. Okay, so because of that, it can accept a proton from, because it has a lone pair, so it can accept a proton. Okay, and then it would become, it can form a dative bond here. Okay, to differentiate, you have to use arrow, pointing from donor to the acceptor. Okay, since it accepts a proton, okay, so that's why you the charge here become positive. And you can write the formula, so N2, so there are 5 hydrogen. 5 and the charge here plus. Okay, next for NH2OH. Okay, so there are 2 center atom. Okay, that is referred to the nitrogen and oxygen. Nitrogen have 1 lone pair, whereas oxygen it has 2 lone pair. Okay, alright. So since the nitrogen have the lone pair, so it can accept a proton. Okay, and it would become also form dative bond. And the charge here become positive. And you can write the formula NH3. Why NH3? So we have 1, 2, 3 hydrogen and OH. And the charge now become positive. C6H5 NH2. Okay, C6H5 NH2 here is actually a benzene ring. Okay, when you write the structure here, actually it is a benzene ring like this. And attached to the nitrogen. Nitrogen have lone pair and attached with the other 2 hydrogen. So because of that, nitrogen have lone pair, so it can accept a proton. Okay, and it will become positive ion. So there would be a formation of dative bond. And the charge here, because accept a proton, so become positive charge. So you can write here C6H5. Okay, and then for the nitrogen, it has 1 more hydrogen, NH3 plus. Okay. Okay, right. So here is the value of Ka and Kb. On the left side is refer to the weak acid, example of weak acid. Okay, and then here is refer to its conjugate. So HNO3 donate a proton. Okay, and it will become conjugate base, that is NO3 minus. Okay, for HNO3, so there is no Ka value and Kb value for the conjugate base. because of it is a strong acid. Okay, so let's say we take a look at HF. So HF is a weak acid. When it donate a proton and it become F minus ion, which refer to the conjugate base. Alright, so we know the relationship here. When Ka is high, so we'll get the value of pKa is low. Okay, and then the concentration of H3O plus will increase. pH will become lower and the acid is more acidic. So when we refer to all the Ka values, okay, so meaning that the higher the value of Ka, the stronger the acid. Among all these weak acid, the strongest here is referred to HF acid. What is the relationship to its conjugate base? So we can see that the conjugate base here, we refer to F minus, the value of Kb is the lowest. Okay, which means that the base here is weaker base, because we know that when Kb is high, pKb become low. So concentration of H plus low because of the concentration of OH minus increase, pH high and become more basic. When refer to all these Kb values, okay, so for the Kb values for F minus is the lowest. So because of that, it become weaker base. So we can conclude that a stronger weak acid, because Ka is high, the conjugate base form, it will have the smallest Kb values. So it become the weaker conjugate base among all. Alright, next for the second question here. Okay, so remember a strong weak base, which means the Kb value would become high. So it has weak conjugate acid. Right, so meaning that the arrangement for this B strength, increasing strength of acid would become inverse. Meaning that the weakest conjugate acid is NH4 plus, this is the weakest, followed by N2H5 plus, next is NH3OH plus, and the strongest is conjugate base of aniline, C6H5 and H3 plus. Okay, for this question is only one question covered. So I think that's all for today. Thank you and Assalamualaikum.